Hi, this is Mr. Kutchell, and today I'm going to talk to you about energy. In particular, I'll be talking about three types: potential energy, kinetic energy, and mechanical energy. Now, what we're going to ask the first question is what is energy? Well, energy is simply the ability to do work. And as we learned in the previous video, work is applying a force over some distance. So if you have an object that has the ability to apply a force over some distance, it has energy. So again, work is force times distance. So anything that can do work has energy. Now, just like work is measured in joules, so is energy. Energy is measured in joules. Now, there are two basic types of energy. One is called potential energy, and we often abbreviate it as PE. And one is kinetic energy, which we often abbreviate as KE. Let's go ahead and take a look at the first type of energy right here, called potential energy. Potential energy is simply stored up energy. It's energy that has the ability to do work. It's not currently doing work, but it has the ability to do work. Let's take a look at a couple of examples. Here's an example of a stretched bow. So you can see the bow is stretched back. The bow is stretched back all the way here. The arrow is sitting there ready to be shot. It hasn't been shot yet, but this string right here that's been stretched can apply some sort of a force to that arrow over some distance. So since it can apply a force to the arrow over some distance, we say it has potential energy. It has the ability to do work. Here's another one. This is called a pile driver. They use this quite often in construction. When they do this, what they do is they have a heavy mass suspended from like a large crane. And so there's a wire that goes up here, and they basically lift this large mass up, and then they drop it. They drop it and allow it to hit these posts, like these over here. And they basically drive these into the ground. And they do this a lot in construction, in building bridges, and so on. So it's very important that they have this ability, but this is all based on potential energy. When you raise that pile up, that heavy mass up, it has potential energy. Another example is when you wind up a spring in a clock. When you wind the spring up, if it was to be let go, it would spread all over the place. So it's got potential energy, and the potential energy is slowly released with the hands of the clock moving. One you might not think of is dynamite. Dynamite has potential energy. It has the potential to release it. It's called chemical potential energy. If this dynamite were to explode, it could apply a force over some distance to objects that are nearby it. So that has potential energy as well. It's called chemical potential energy. Another example would be a mousetrap. Look at this mousetrap here, and of course we got the smart mouse. Don't worry, he's not going to be hurt. He's got a string he's attached to the cheese, so he's going to get the cheese anyways. But the wily man that thinks he's going to get him has pulled back on this wire, and it winds this spring up tighter. And when this cheese is pulled out, snap goes the trap and misses the mouse. So that's potential energy waiting to be released. Now, another very common one would be what you see here, like the Hoover Dam. In the Hoover Dam, they basically have water back here that's been raised up, and they build these along rivers that have great big valleys here. So that backed up water has the ability to run down these channels that go behind the dam and do work on different machines to make electricity. So when we're taking a look at gravitational potential energy, which is what this is, gravitational potential energy depends on the force due to the weight and height of the objects. So we can say potential energy is mass times the acceleration of gravity, which is simply weight, times the height. So weight times height is potential energy. The greater the mass or height, the greater potential energy you get out. Let's go ahead and take a look at another example. Here you have a pendulum. The pendulum starts up here, it's let go, and it starts to go faster and faster and faster, but now it's at its lowest point. It can't go any further down than this because the string won't allow it to. So then it will swing back up here, and it will gain potential energy. When it comes back down here, it will lose potential energy, and then it will gain potential energy, and so on. So where's the greatest potential energy? At the top of the swing. Why? That's where it has the most height. Now the amount of potential energy an object has doesn't matter in how it gets there. For example, if we just tossed a stone up here, or a rock up here, and it's sitting up here, it has potential energy because it's above the ground down here. If we built a ramp right here, if there's a ramp that was built right along here, and we pushed that stone or that rock up there, it still has the same amount of potential energy as over here, because remember, potential energy is the weight times the height. And in this case, the weight is 200 newtons times the height is 2 meters. So it's going to have 400 joules of potential energy. The third situation over here, it was pushed up this little stair step. Still, same potential energy because still it has the same weight and the same height. Let's go ahead and take a look at a practice problem here. If it says calculate the potential energy, okay, potential energy, let me write down the formula. PE equals M times G, times G times H. So calculate the potential energy, we're going to do that, of a 3 kilogram bowling ball, so 3 kilograms, on the top of a 2.5 meter hill. Well, we got to multiply our mass times G, which is 10 meters per second squared. And then we have to multiply that by the height it is above the ground, which is 2.5 meters. Well, ultimately, when we do that, we're going to get 3 times 10 is 30, times 2.5 is 75. This will give us 75 joules of potential energy. The second type of energy is called kinetic energy. And kinetic energy is the energy of motion. When something's moving, it has the potential to apply a force over some distance. Now, kinetic energy is a very important concept. This formula right here you will see in lots of different things. In fact, this is directly related to temperature. When you're measuring the temperature of an object, you're actually measuring the average kinetic energy of that object, but that's chemistry. All right, so kinetic energy is simply 1/2 the mass of an object times its velocity squared. Since we're doing this all in SI units, because it's energy, it will be measured in joules. So let's go ahead and take a look at a practice problem here. Or let's take a couple examples here. Here we have a bow in which the string has been released. The arrow is now flying through the air. So that potential energy that was once here is now been transferred to the kinetic energy of this arrow. So the arrow is flying through the air, and because it's flying through the air, it can apply a force over some distance to an object when it hits it. So it's going to have energy, and that energy of motion is called kinetic energy. So here's the practice problems we're thinking of. First, we're going to calculate the kinetic energy, and kinetic energy is 1/2 mv squared. And I'm going to go ahead and solve this problem because they give us the mass. We know the mass, 2,000 kilograms, and we know the velocity is 10 meters per second. So we're going to go ahead and take 1/2 of the mass, which is 2,000 kilograms, times, and here's the important part, the velocity squared. Make sure it's the velocity squared. So it's 10 meters per second, and we got to square it. What do we square? We only square the value of 10. So it's 10 times 10, which is 100, times 2,000 is 200,000, divided by 2 will give us our final answer, which is 100,000. What are the units for energy? Joules. So it's 100,000 joules. Let's do another problem here. This problem says a bowling ball travels 2 meters per second. Okay, that's my velocity, is 2 meters per second. Down a lane with 16 joules of kinetic energy. So kinetic energy equals 16 joules. Find the mass of the bowling ball in kilograms. So mass equals question mark. I'm going to go ahead and solve this. I know that the kinetic energy is going to equal 1/2 the mass times the velocity squared. That's my original equation. Now I'm going to multiply both sides by 2. Multiply this side by 2 and this side by 2. So my new equation is 2 times the kinetic energy equals the mass times the velocity squared. But I'm trying to solve it for mass. So the next step I'm going to take is divide this side by v squared. Divide this side by v squared. These cancel. So my mass is going to be 2 times the kinetic energy divided by v squared. Plugging my numbers in, that's going to be 2 times 16 joules, all divided by the velocity squared, which is going to be 2 meters per second, which we're going to square. 2 times 16 is 32, divided by 4. 32 divided by 4 is going to give me 8 joules as my final answer. So in summary, here's the two big pieces you should pick up from this. Potential energy is the energy something has due to its position, and it's related to mgh when we're talking about gravitational potential energy. And the other energy is kinetic energy, and kinetic energy is 1/2 the mass times the velocity squared. Now in future videos, what you're going to see is that these two are related, and that's called the conservation of energy, and it's very important. Well, I hope you all have a great day. I'm running out of energy. Gotta go. Bye-bye now.